Wireless Local Area Network, WLAN. A wireless local area network, or WLAN, is the invisible extension of your wired infrastructure. It takes the privately owned, high-speed environment of the standard LAN and completely removes the physical tether, allowing laptops, tablets, and smartphones to roam freely while maintaining a constant connection to the local network. For your CompTIA A+ exam, you must understand the hardware that bridges the gap between the air and the wire, the specific radio frequencies involved, the two primary modes of operation, and the severe security risks introduced when you broadcast your data into the open air. The foundation, the 802.11 standard. A WLAN does not use proprietary magic. It operates strictly under the IEEE 802.11 family of standards, universally known as Wi-Fi. Instead of sending electrical pulses down a copper wire, a WLAN transmits digital ones and zeros using radio frequency, specifically in the 2.4 GHz and 5 GHz bands. The 2.4 GHz band is excellent at punching through solid objects, like the walls of a house, and covering a wide area. However, it is incredibly crowded. Microwaves, baby monitors, and your neighbor's router all use this same space, which causes severe interference. The 5 GHz band provides massively wider channels for incredibly fast data transfer. But the radio waves are shorter and more fragile. They cannot penetrate brick or heavy timber easily, meaning the range is significantly reduced. The hardware, the wireless access point. The most critical component of a WLAN is the WAP, or wireless access point. A common misconception is that a WAP is the same thing as a router. It is not. A router's job is to connect two different networks together, like your LAN to the internet. An access point is strictly a Layer 2 bridge. It has an antenna on one side to catch the radio waves, and a physical Ethernet port on the other side that plugs directly into your local switch. Its only job is to translate the wireless 802.11 frames flying through the air into standard Ethernet frames that the wired network can understand. In a typical home setup, the router, the switch, and the access point are all crammed into one single plastic box. But in an enterprise environment, or a dedicated home lab running multiple servers, the roles are separated. You will have a dedicated router in the rack, and multiple WAPs mounted on the ceilings throughout the building to create a massive, overlapping blanket of wireless coverage. Operational modes, infrastructure versus ad hoc. When configuring a WLAN, you must know the difference between the two primary network topologies. The first is infrastructure mode. This is the standard deployment you use every day. Every wireless device, whether it is your phone or a smart television, connects to a central wireless access point. The devices do not talk directly to each other. All traffic must flow through the central WAP. The second is ad hoc mode. In this setup, there is no central access point at all. The wireless devices connect directly to each other in a decentralized, peer-to-peer mesh. If you are out camping at a national park with no cell service and no router, you could configure two laptops in ad hoc mode to share files directly over the air across the campsite. The cybersecurity perspective, securing the airwaves. From an ethical hacking and security perspective, a WLAN is inherently dangerous. When data travels over a wired LAN, an attacker must physically enter the building and plug into a switch to intercept the traffic. But on a WLAN, your network traffic is being broadcast into the street. Anyone sitting in a car outside your house with a high-gain antenna and a packet sniffer can capture your data. Because of this, robust encryption is absolutely mandatory. You must ensure the WLAN is using WPA2 or the modern WPA3 Wi-Fi protected access protocols. These standards use powerful mathematical algorithms, like AES, to scramble the data before it leaves your laptop's antenna, even if an attacker captures the radio waves. They will only see unreadable gibberish. You must also be vigilant against rogue access points and evil twins. This is a classic penetration testing technique where an attacker sets up their own WAP nearby with the exact same name as your network. If your device connects to the attacker's fake network instead of the real one, the attacker can execute a devastating man-in-the-middle attack. Contrast and comparison for the A+ exam. To ensure you have this locked down for the exam, contrast the WLAN with the other networks we have built. WLAN versus LAN, both are locally owned and operated, but the wired LAN offers superior stability, lower latency, and absolute physical security. The WLAN sacrifices a degree of stability and security in exchange for total user mobility. WLAN versus PAN. A PAN uses Bluetooth to connect personal devices within a 10-meter bubble around your body. A WLAN uses Wi-Fi to provide high-speed internet access across an entire house or office floor. WLAN versus WWAN, cellular. You own the access points in your WLAN and manage the local traffic for free. A WWAN connects you to a remote cell tower owned by a provider, and you pay for the data you consume. By mastering the transition from the physical copper wire to the invisible radio waves of the WLAN, you are now ready to dig into the specific protocols that make it all work.